Okay, so this is day 2 on vectors. This is worksheet 1, side B. Is that correct, guys?
Yeah.
On section 8.1. All right, towards the bottom is this question, and we're going to do it twice with 2 different methods, and you can pick which one you like better. It says, first of all, I should use my line tool here to... All right, a helicopter is moving 15 degrees north of east. When they write it out like this, it just means to the north of east. So the 15 degrees is in here. Off of east, 15 degrees towards the north. If we wrote it in this notation, it would look like this. Off of east, 15 degrees toward the north, okay? Could they make this any more confusing? I know. They write things like 3 different ways and expect you to understand all of them. All right. It has a velocity of 52 kilometers per hour. So can we do the components of that one right now? Then I'll confuse you with the wind, okay? Do you remember yesterday how we did components? We used r cosine of theta and r sine of theta. Does that sound familiar? So to break this down into its x and y components here, x would be adjacent, so it's cosine. So it's 52 cosine of 15 degrees and 52 sine of 15 degrees. I always have students who do that backwards. They want to do 15 cosine of 52. I hope it makes sense to you that the 15 is degrees and it has to go with the cosine, okay? That part should be fairly straightforward. Okay, somebody want to type those in, give me some decimals?
50.2 and 13.5.
Thanks, Getty. You rock. All right. The second part, no? Did someone else get that? I thought I heard somebody say they didn't get that. Yes? Okay. The second part says, if a 30 kilometer per hour wind is blowing from a bearing of 250. All right. We got so much going on here. It's from, and it's a bearing of 250. What does a bearing mean? Do you remember from yesterday? Off of due north. Okay. So let me see if I move this a little bit down. I'm going to do it on a separate one to start because it's going to have a bunch of garbage on it. Okay, this is what it's saying. It says off of here, 250 degrees. Can you tell me something about 250? That would be 90 here, 90 here, and how much more? Everybody okay with 70? 90, 90, and 70 makes 250. Is everybody okay? Okay. Now that I've messed up already. The arrow is not here. Matter of fact, this is more like a dotted line because remember this is where it's blowing from. So here's Mr. Wind and he's actually pushing it this way. He needs eyeballs. Okay. Do you get what I'm saying? He's standing at that spot and he's pushing it this way. All right, now we need to figure out for components, what we need to figure out is this angle with the x-axis. Any ideas? If this is a 70, this up here is a 70, and this therefore is a 20. Everybody okay? And that wind is blowing how hard? 30 kilometers per hour? So the components of the wind are 30 cosine of 20 and 30 sine of 20. Anybody got those numbers for me?
28.2.
Anybody else do those and get those same numbers? Okay. Now, I'm going to go back and draw this up here. the wind is actually just 5 degrees different, right? We said 20 degrees up instead of 15. You with me? And it's over half as long. It's a 30 kilometer per hour. And this little angle in here is 5. Okay. What I want you to see by putting them both on there is these forces are largely acting together, right? They're almost on top of each other. So if the wind were directly behind the helicopter's speed would actually be 82 kilometers per hour. Do you get that, guys?
Yeah.
Because the wind would be pushing it straight on another 30. It's off by a little bit, and we got to figure out what's happening. All right, so what we do is we add to find the resultant. We add this number to this number and get 78.4. Does that look good? And then we add this number to this number and get 23.8. So we add the x's together from the wind and the plane, and we add the y's together. We all good? Okay. This means that let me do a third drawing now that you're ready to shoot me. Okay, the resulting concept here is this vector. What happens when we put these together? It goes over 78.4 and up 23.8. We need to know its magnitude or length, so we need to do what? We talked about this yesterday, but does it make sense when you see my picture? We need to do Pythagorean theorem. Okay, so the magnitude of the resultant is 78.4 squared plus 23.8 squared, and then we get a, whoa, that's a weird squared, Hofbauer. And then we got to square root all that. Anybody get an answer? 81.9 kilometers per hour. Does that make sense, guys? Remember we said if we pushed it right on top of each other, it'd be 82. It's almost 82. And actually, it might be off by a little bit because we rounded twice already, right, before we got to here. So, all right. The other thing we need to know is how much off course the wind is pushing this. So we need to find this angle in here. How can we do that? Opposite over adjacent? Can we use inverse tangent? Okay, so we're going to do inverse tangent of y over x to get our angle. For this particular problem, that means we're going to do inverse tangent of 23.8 over 78.4. Anybody got an angle for me? 16.9 degrees. Okay. Now I want you to look back up here. Does it make sense that the resultant is that this wind is pushing the plane? It was trying to go 15, the wind was blowing at 20, so it's at 16.9 in there somewhere. Does that make sense? Okay. I'm going to undo that scribbly, so when I get to print the notes, it's not quite so scribbly. The final thing we might want to do is change that to a bearing, because we could say 16.9, we could leave it. We could say north of east, or we could say off of east, go 16.9 to the north. We could also change it to a bearing. Can anybody tell me, without being totally confused, the bearing is just this number, right? Off of north. Yeah. So if this is 16.9, this one's really not hard to find. 73.1. All right. All that fun. Okay. If you're in physics right now, I don't think you do them this way. This particular, from what I've heard, the physics teachers aren't using law of sines and cosines. Does that sound right? Okay. So I'd really like you to pay attention and watch this method. I'm gonna this time exaggerate, because there's a time when this method is really easier than the other, okay? Not often. I mostly use components, but I'm gonna exaggerate the angles just because I need some room to work this time, okay? When it says same exact problem, so it's 15 degrees here, and this is 52. This is going to go faster, kilometers per hour, okay? Because we already drew the other picture, remember what happened was it wound up here. The wind was pushing from over here, and this was 70 degrees, remember? And this one was 20. So this angle in here was 5. Does that all sound familiar off the work we did earlier?
Yes.
Unfortunately, people think, well, is this method easier? We still would have had to go through all that rigmarole to find this 5-degree angle, okay? I made it look easy because we already did it on the other picture. All right, this concept is what you have to do is take one of these vectors, like this one right here, and slide it out here. Now, I have exaggerated this to the point that it's going to go off the paper. Let me do a little repair work here. All right, the idea is you slide this vector out here. No, not like that. I'll try one more time. So that it is a parallelogram. Does anyone see the little parallelogram that I'm attempting to draw here? These are supposed to be parallel, and these are supposed to be parallel. Okay? It's a really tiny little parallelogram because remember this was 5. I don't know if you remember anything from geometry, but that means that angle's 5 across the parallelogram. Do you remember what that makes this angle then? We talked about this when we did law of sines and cosines. 175. Those are supplementary. Okay. How long is this blue vector? 30. Okay. The resultant is what happens here through the middle. Okay. I'm going to exaggerate even more by bringing this down here. We have a 52 here. We have a 30 here. And in between we have 175 degrees. Can we find this distance? We can find that value, which I attempted to call x very crookedly. By what? Law of cosines. So I want everybody to type 52 squared plus 30 squared minus 2 times 52 times 30 times the cosine of 175. And then square root. After you square rooted, right? You got 81.9 kilometers per hour. Does that sound familiar? Okay. It seemed a little bit easier, but remember we skipped all the fun at the beginning of finding that angle, okay? The other thing we would need to find is the angle that it's pushing it off in here, which is actually this angle. Look at my picture. I should write the 52 out here and not in here, but the sine of that angle theta, I'm using law of sines here, is across from a side that's 30. Everybody okay? In the same way, the sine of 175 is across from a side that's x, which we just found was 81.9. All right, cross multiply, divide, we get the sine of theta is 0.0319. Anybody get that? But to find the angle, we have to do inverse sine of what am I doing? I got 1.8. That doesn't. Oh, is that right? That is right. Is it 1.8? 1.9? I did it round. It should be 1.9 actually, I think, but I don't know. Somewhere around 1.8 or 1.9 is the angle in there. But remember, that's how much further it pushed it. So if we took 15 plus that, we'd get 16.8 or 16.9 degrees off east. Is that the same thing we got on the last one? Okay.
So say 0.0319 or 0.6.
No, this is a 0. I just did the cross multiply and divide. 30. Yeah. But see, we rounded like 10 times along the way. That's why it's off a little bit. I just want, first period when we did this problem, people kept telling me the answer was this. You remember at the end of law of sines you have to do second sign? Everybody remembers? Okay. All right. That's the end of day 1 notes. Don't cry. Okay. We're going to go on to day 2, and we're going to do a little tiny bit of review, and then we're going to do some applications. All right. Couple really quick, I'm not even going to type these. I want you to type them on your paper. 60 meters at a bearing of. What does this mean? I hate that it's 45 again, but it means off of what? North, go towards the east, 45. Gotta redo these notes for next year and change all these 45s. Okay, it does mean its component is also going to use 45 off the positive x-axis, right? And it's 60 meters long. It says, draw an arrow diagram, include labels, find the component form. So what are you going to type for component form?
60
Okay, and I'm going to go with, actually, since these are your notes, let's not even bother to type. Is that okay? Keep going? You know how to do it, right? Okay. What about over here? 60 degrees to the horizontal means? Yes, to the horizontal means you're going around off the positive x-axis. So it says 100 pounds of force at 60 degrees here. So it would just be what?
100 cosine 60, 100 sine 60.
You are good. Everybody okay? I know you could type those in if you needed to. All right, we already talked about this to and from business. Here we go. We got a grocery example. It says, everybody awake?
Yeah.
I see some sleepiness. Stick with us for a couple more examples here. Caroline walks 40 kilometers north of, 45, I can read, north of west. So off of west towards the north, really doesn't matter because it's right through the middle. Okay, 1,000 feet. Her apartment is at the origin here, okay? Then walks 200 feet due north. Now, you have two options. You can put that here, because it says then, right? Which is 200 feet due north. Or you could make it a second vector here, 200 feet due north. We just need to figure out where she ends up. So you have two options. If you're going to do component form, you need to make sure that she ends up out here somewhere, right guys? This is where she ends up, way out there. And that's the crookedest line ever. Let me see if I can fake it with my line tool here. So where she actually ends up is from there to there. All right. Let's talk about the components. What are the components we're going to use for this guy, the red one? Okay, you can, if you are used to doing in physics 1,000 cosine 45, 1,000 sine 45, you can do that. You're going to have to remember, though, that it's acting to the left, right? So you're going to have to subtract later or whatever you're going to do. I've suggested that we always use off the positive x-axis, so that would actually be 135, because that will take care of the signs for us. You can do the signs on your own. You'll get the same decimals, I promise. Whoops, oops, oops, not if you type cosine twice so far. Actually, you would. Because the sine of 45 and the cosine of 135 are the same. All right. And what are the components for the blue vector? Whichever blue one we want to talk about. Don't make this harder than it is, guys. How do you get from the origin out to the end of a 200-foot-long segment? You could. But what are the components just going to be? Tell me how to get there. I go over 0 and up. Okay? If you did 200 cosine 90 and 200 sine 90, it would work, okay? All right. To find the resultant, we need to add those. So I didn't bother to type it in until now, because I'm just going to type them in and then I won't have rounded quite as many times. 1,000 cosine of 135 plus 0 is? Okay, 1,000 sine of 135 plus 200. Okay, how do we find out how far away she is? That means the magnitude, so we have to do what? Yep. It's a ginormous number, and then you square root and you get around 1,150, whoops, if I could write. Kilometers, meters, feet from her apartment. Okay? And then it says, at what north of west quadrant bearing is Caroline from our apartment? All right, how did we do that before? When we had components, we did inverse tangent, or we can do law of sines. Yep, we can figure that out. Inverse tangent of 907.1 over negative 707.1. Can you try that? You're going to get a weird answer. Whenever you do negative inverse tangent of a negative number, remember it assumes you're in the fourth quadrant because inverse tangent is only defined there. Okay, so the calculator thinks we're down here 52.1 degrees this way. Does that look right? But is there a vertical angle that you know? If that's 52.1, isn't this also 52.1? Now, what did they want us to do? At what north of west? Well, isn't that exactly north of west? 52.1 north of west, yes? To the north, off of west, 52.1. I'm sorry, I kind of ran out of room down there. Do you see the vertical angles there, though?
Yeah.
All right. This one actually would have been pretty easy to do by law of cosines, and I won't make you redo it again, but what would this angle in here be? Can anybody figure that out? If this was 45 in here between the red and the black, then this is 45 down here, right? By alternate interior angles, do you see the Z? And this is a 90. So 45 and 90 made that 135 in there. Okay? So then you could have done 1,000 squared plus 200 squared minus 2 times 1,000 times 200 times the cosine of 135 and square rooted it, blah, blah, blah. All right. Let's try this. They're not all that complicated. Some of them don't have two forces, or that, I didn't think that was actually horrible. I don't know what you thought, but goodness gracious, what am I doing here? I'm trying to just move this up. There we go. Okay, Roland is pulling a crate of construction materials with a force of 60 newtons at an angle of 42 with the horizon. Draw a diagram. Now the book thinks we're going to get out our compass and protractor and choose a scale and ruler and all kinds of good stuff. We're not. We're going to do this, yes? Okay. And then down here, it also shows the resolution into rectangular coordinates, which is basically the horizontal and vertical components. So let's just talk about B. Horizontal means what? Side to side, which is the x component, yes?
Yeah.
So we're going to do 60 cosine of 42 degrees. Anybody get a number?
44.6.
So it's 44.6 newtons of force horizontally. And vertically is what? Vertical up and down is the y component over here. So it's 60 sine of 42, which was what, Getty? I'm sorry?
40.1.
Newtons of force across. So how could we check that that's 60? We could do Pythagorean theorem with those numbers if we wanted, right? Just for a good time, and we should get close to 60. Okay. That's all there is to that one. Unfortunately, not the case with this one. Here we go. Airplane is flying with an airspeed of 500 miles per hour at a heading due north. Oh, that's nice. Okay, so we have due north. If a 50 mile per hour wind is blowing at a bearing of 270, okay. Do you remember what at meant? First of all, bearing of 270 is not down here. Because bearing of 270 means 270 degrees off of there, right? Okay. From 270 would mean it was blowing it back this way, but at 270 means it's blowing it that way. And it's blowing 50 miles per hour. Okay. If we were doing an accurate representation, this is not good because this should be 1/10 as long as the other one, right? 50 and 500, yeah, this one would be way shorter, but we're going to go with it. All right, what do you want to do? Do you want to do law of cosines? Mm-hmm. If we slid that one up there and drew this resultant in, this is a 90-degree angle and this is 50. You could actually just do Pythagorean theorem because it's making a 90, right? Just humor me, somebody. What are the components of the red one? What gets it straight up 500? Across 0 and what would get this blue one to the left 50? There we go. And so the resultant is, which means Pythagorean theorem should work, yes? Which we just drew this way to show that it would work either way. All right, somebody's typing away. .5. Did someone else get only 502? Okay. Miles per hour. Why is it not that much over less or over 500? Anybody describe that in real terms here? It's only 1/10 of the speed of the plane, but it's also like totally a crosswind, right? It's not helping the plane hardly at all, and it's not hurting the plane hardly at all in terms of speed. It helped it 2.5 kilometers per miles per hour. Not much. All right, but it is going to push it off a little bit, right?
Yeah.
Off course. So we need to find an angle in this picture. If we do, let's see, which angle should we find? We can do law of sines. We can do inverse tangent. If we do inverse tangent, it's actually going to find us this one, which is this angle in here, which is okay if we don't, they don't specify how we have to state the bearing direction. Okay. If we do inverse tangent, 500 over negative 50, we're going to get a negative angle. What do we get? All right, that means that it thinks we're down here, negative 84.3, but we're actually up here. Whoa, bad drawing. Let me try that again. It thinks we're down here, 84.3. The calculator has misinformed us. We're actually up this way, 84.3. So do you want to use that number and say off of west? Or would you rather talk about this angle in here? Off of west? You can. Actually, I want to know how far it's blowing it off because the plane thinks it was going this way. So could you just subtract from 90 for me? Is it 5.7? So it's blowing the plane 5.7 degrees off of north. 5.7 degrees off of north towards the west, right? To find a bearing, how would you do that? If this angle in here is 5.7, the bearing is actually all the way around, right? 303, 50 something. Thank you. All right. On a test or quiz, I would specify when we get to that point which one I wanted. All right, guys. Can I ask you to attempt to break this into components, please? And I'm going to wander around for a minute because too many of you are sleeping. Find the components for tractor 1 and find the components for tractor 2, and then add them together and see what you get. When you add them, if you're using the Precalc method, you're going to want to use a negative 20 down there. If you're using the physics method, you're just going to remember that it's subtracted because it's going down. Which other angle? Well, no, because this one's already giving us that this is 20 and this is negative 20. So we can just type them in. Josh, did you get the components for tractor 1 or not? Cole, did you type them in? Igor, do you have tractor 1 done? Yep. Which made it, did you type them in already or not? Okay. Amanda, do you have this one?
Yes. I 1,409.
It's close enough. I don't care.
And 513. Yeah, I realized it.
That's okay. All right. So what is the sum of the horizontal components? What is they asking us? Just to add which ones? Horizontal, yeah, the cosine or the x ones. So what's the sum for the x? I don't know. Somebody add those together for me. Something like that. And the sum of the vertical? Yeah, actually, this one should be negative, right? If you use negative 20, did you get negative?
Yeah.
Okay, so negative 171-ish, depending what, if you left decimals on. Okay, so that's newtons of force horizontally, and this is up and down. So if the stump were to fly out of the ground right now, it would fly forward, but it would also go a little bit further towards truck 1, right? Because it's pulling harder, or it's got more newtons of force. Okay. B says, what is the resulting, oh, why do we have that twice? Force on the tree stump. I don't know why I have this on here. So we need to do what? Add the two forces together, but then do what? Pythagorean theorem, yes. Because the resulting vector goes, yeah, 32, 88 this way, and 171 this way. So we need to do Pythagorean theorem. These are the numbers we just found. We just need to do Pythagorean theorem. Anybody? Okay, let me ask you this. Before I look at their question C, what would happen if they pulled at 10 degrees each instead of 20? Do you think it would pull with more force or less force? This total resultant force. It would be more force, right? Because if this was only 10, they're acting more in the same direction, right? You could get 3,500 pounds of force if they were doing what? Or newtons of force if they were pulling in exactly the same direction, yes? Okay? So the closer they are to the same direction, the more force we're going to get to combine. All right, this question, though, is a little bit different. It says, what happens if it was 40 degrees, but they moved? Like this one was 30 and this one was 10. Do you think that would change? The total force?
How would that be possible? Yeah, it's 4 degrees in total.
Yes. It would not change. It would not change the total resultant force. It would change where the stump went flying, right? it would change the y value, but it would actually change the x as well. But the total when we did Pythagorean theorem would still be this. Okay.
You get a bigger y value and shorter x value.
My example where we went 30 and 10, yes. Bigger y, shorter x, yes. All right, guys. Let's look at this question 8 real quick. Person in a canoe wants to cross a 65-foot river. He begins to paddle straight across. Okay, so here's the river. He's going straight across. Okay, if I could draw. At 1.2 meters per second. The current is flowing perpendicular to the canoe, so the current is going this way at a perpendicular. If the resulting velocity is 3.2, what is the speed of the current? So this is 3.2, guys. What happens when, okay, let's say the current's pushing him this way. He's actually moving 3.2 here. So we just need to undo Pythagorean theorem. I knew we could do this one quick. Anybody else get 3?
Round up.
Yeah, about 2.97 or around 3 meters per second. Okay, so don't think that every question is going to be a horrible 17 parts, okay? They're not all.
Possibility.
It's a possibility, but